Okay, that was it so far. We have finished our project about the battery monitor. My name is Roland. Thank you everybody who was following the series and also gave some comments. The controller is working very well. We have a working app. Everything looks nice. So this video is all about a short talk. What could we do different, what could we do better? Because this, how we did it, is like a prototype. I used components which I had here. I used my board from my controller in the Powerwall, and that one was built for the Arduino Maker Pro, so I used that one. But of course, if this would have to be done as a product, I would go for some other components, like another microcontroller. Probably I would go for the ESP8266 Node MCU or something like this. You already have Wi-Fi, we only need a few pins, and then that kind of microcontroller you can buy for, let's say, $3–4. Well, this combination which I've used now costs between $13 and $15, so you can easily save another $10 there. Another option would be going with something like this, a STM32, and this also just costs a couple of dollars, and you don't run into memory issues like with the Nano. So the monitor as it is now is a passive monitor. We are just taking measurements. We take current, we take voltage, we calculate a little bit, and we present this as information on the screen. But we can turn this also into some active device just by using maybe something like this. This is a board with 2 relays on it, and we could reprogram, of course, the microcontroller to switch relays according state of charge, for example. So let's say once we reach 90% state of charge and we still have daytime left and solar energy would be available, we can start diverting energy into, let's say, hot water, or maybe you have a well pump, you start pumping water from the ground into a tank or something like that. That would be just 2 simple examples how you could turn this also into something active. So if you have maybe some ideas what could be still done with this device to do some certain tasks, please leave your comments, and if somebody is reading this, he can get some extra ideas. Yeah, so there was only one real challenge in this project, and it was to get clean measurements because of the electrical noise and this kind of stuff, but we did it quite okay. Of course, somebody who would like to have even better measurement results could apply an extra digital filter. This is all, of course, possible with microcontrollers. We have used some different sensors. For example, you know, measuring high currents with Arduino, with microcontrollers, there's not many solutions there on the market. There's only one more sensor who is built for that. That is the ACS758, which goes up to 200 amps. It's a Hall effect sensor. You can find breakout boards or just a chip. Also some little bit better boards, better designed boards. But all of this, you know, we have so nice big cables here on the battery. Altering something with small flimsy cables onto these small boards, I think this solution is the solid one, right? And I cannot tell you if the measurement quality of those Hall effect sensors, how they react to noise, etc. I don't have any experience with that. Okay, so there's not much for me to say anymore. Please leave your comments in the comment section, what we could have done better or different. And otherwise, if you liked the project, give me a thumbs up, subscribe the channel, and I see you next time.